is the Kepler's problems, and Kepler's problem is this. So this is the orbit. So here we know the R1 and we know the V1. And we want to know the, say, given the time of flight. So from here to here, let me call it dt, time of flight. Then we want to determine is the value R2 and V2. Okay, so that is the prediction problem. Prediction, that means if our radar site, we can have this information be measured at this moment, then we can have all these things be calculated and we can predict when the object will be shown up in where in space, okay, by certain amount of time. And Gauss problem is this. And we are knowing R1 and R2. And basically that is a transfer problem, and we want to determine what is V1 and what is the V2. And also we are given the time of flight. Okay. So for this one, this is kind of the boundary problems. And in practice, we're going to combine the two techniques and to solve for very practical conditions. So here, this is our focus today. I'm going to talk about two the applications, and the two are from our textbook. And the first one is the interceptions problems. So here, for example, you can see we have things being knowing we know the R1, V1 at this moment. We know the positions R1, and we know how much time we're going to spend doing the transfer and to reach the target. And here we know the R2 of the target. So in this way, we should be able to calculate how much will be the appropriate velocity here. We need to boost up and to arrive our destination in the given time. Okay. And so to that moment, we can also determine how much energy, how much delta V we need to adjust to meet this target here. Okay, so that is the one of the applications, radar boost problems. And the second one is this. This is from the Earth's surface. And here we know in R1, we know in R2, which means we know the R1, R2 basically is the radius of the city, but with a different locations. And for this problem, if we given R1, R2, and also if we given the time of flight, and which means 25 minutes of the free flight in space and to target to the ballistic missile. Okay, so in this way, we will be able to calculate how much the fuel, how big the rocket need to be to complete these missions, and then from there we can know what is the impact velocity there. This topic is the ballistic missile, the targeting problems, and I'm going to spend our next chapters, chapter 6, I'm going to talk about this one. Okay. So basically here this is the practical applications, and I'm going to spend a little bit more time today about this one. So that will be part of your